So, let's see here. Next tool. This tool is tool number 2. I've only done 2 tools. So next tool is T303. This is going to be a. I'm always in the habit of doing my smallest drills first. So we'll drill the .203 holes for the 1/4 20 tap. And kind of just can go by this. We can say a little bit of a safe start line here would be like G0, G54. Yeah, they don't really give a whole lot of safe start information on that example. And they are in G19, G98. So all those, you'll notice in this example, the codes are placed in a little bit different order. So it just kind of lets you know that there's not one hard set way to do this until we get out to the lab and figure out the lathes alarming out, because it won't do it the way we wanted.
G40.
Well, that is more of a first line safe start. So I don't typically put that in.
I put it in every one.
You do? All right. Well, we can put it in there. G40. That's going to be about it there. So we can wrap it down to the front of the tool. ZCX 2.2.5, V.1, and turn on the coolant, M8. And where are they turning on there? Right here.
Oh, I can't see it. Way too small.
Yeah, that's one nice thing about having it recorded, but I mean, it's not like anybody wants to come back through and watch us twice. I put it up there for folks that, you know, maybe want to have a question about something, or if they just couldn't make it for some reason. It's there. It's there if you need it. Just kind of like the National Guard, you know. M154, M133. These are all codes that are basically getting this spindle turned on. So M154 C-axis engage, and M133 is live tool drive forward. So we need to give it an RPM here. And I think we have a limit of 3,000 on the Haas. But truly, if we're just using a high-speed steel drill, it probably wouldn't be that fast. 3.820 times would be 140 surface feet. Because we're mob carbon steel with high-speed steel divided by 0.203 is gonna. Yeah, I guess it would be about 2,600 RPM. So there you go. S, we'll go 2,500. M3, or no, M133. As live tooling codes, a lot of times will have their own M code for turning the coolant on. And the other thing is not the coolant, the RPM. It's a P value instead of an S.
So that's. Oh, I gotcha. So the M133 turns it on.
Yeah, so these two lines here are kind of like a S2500 M3. Haas gives you a distinction because just in case you wanted to, for some reason, run the spindle of the machine and the live tooling, the machine would know which was which. And we're going to turn on G19, which turns it into YZ plane. Because we are using Y. Sometimes once again, the live tooling planes don't make a lot of sense to me. Turn it into inches per minute, and the reason for that is because the spindle of the cutting tool RPM is not going to change based on the diameter, so we leave it in inches per minute.
Ethan says, I thought it needed to be a P because G50 has the S. S what?
I don't know about G50, but the lathe function of the machine is the S value, would be an S for RPM, whereas the live tooling is a P.
Oh, I see.
I don't think G50. What is G50?
G50 is
That's a
not
spindle.
spindle
Oh
clamp.
yeah,
It's
okay.
governor.
Yeah, it's the
Spindle governor.
spindle clamp or governor. So it limits the RPM. So if you say G50 S2500, the spindle would not go over that. And so kind of the difference is that that's used for constant surface feet, because when you got G96 turned on, which is constant surface feet for turning, the spindle varies RPM based on what diameter the tool's at. Whereas when we're in live tooling, your RPM is not going to vary because the diameter of the tool never changes. Whereas with lathe turning, the diameter of the part changes, so your surface feet is going to change for each diameter that you're cutting at. If that makes sense. All right, so back to the example. So it's pretty much just rapiding and using in place and using a G241 cycle, which we'll revisit. Let's look at our drawing here. So the 1/4-20 tapped holes are these 4 holes on top, so they should be pretty cut and dry. No pun intended. All right, so if you remember right, our Y position is based off of the center line. So it would be, our Y would be half of this 880. Our X will be, if we were going to take it right to that surface, remember it's going to be that 1.622, which is basically the 811 dimension multiplied by 2. 811 times 2, 1.622, but we don't want to take it right there because that would actually potentially hit the drill. So we need to zero out C first, because right now we're just kind of, I think we left it over here at C, whatever this is, 270 minus 15.
270, yeah.
And so we'll say C0, and we're at X. We could probably move Y at this point too, without hitting anything. We'll say Y 0.440. And once C's at 0 and Y's at 0.40, well, technically we're in the clear anyway, so we could actually move everything at once. It would be kind of harrowing to watch. So we'll move C last thing after Z is already put in place. So Z, we've got the point, probably want to make a note that the drill programmed on center of drill. Nice thing about Notepad is if I make this bigger, that will actually go to the right line. So yeah, it can be kind of confusing. Yes, no decimal on C0. Chris texted me. By the way, you can text questions too. I've got my phone right here. When you tell the machine to go to C0 or Z0 or any other 0, there's no decimal needed for 0. Because like my dad always used to say when I was growing up and I was lazy and I didn't want to work, he'd say, son, 0 from 0 is still 0. In other words, if you don't make any money, you're not making any money, which it's funny how those little dad-isms kind of stick with you. I tell my kids the same thing, but they actually want to work, so... I'm like, no, you can't really go out and get a job right now because you'll come home with the coronavirus.
Right.
Yeah. So we're going to move our Z into position, which would be this minus 0.169, because the front of our part is actually C0. C minus 0.169.
Z0.
Z0. Let's see, well, we're coming up on 9 o'clock here, so we'll probably get this done, and then we'll start introducing polar milling, which will be great, because we've really got 4 more projects to program. I know Chris and Sam have already programmed the YC project, which is pretty outstanding. They went through and figured out how to do it and did a pretty good job on that. So you guys will be able to play hooky that day. Let's see here. So we need to go in and just pretty much call up this G241 cycle, and look at my cheat sheet here. G241 is a cross-working drill cycle. It uses plane selection G19, and as far as the feed, it is a G98, which we've already turned all that on. G40, so it's got a G75 also listed there. It says drill with PEC. I think G75 is kind of like a shallow pecking cycle, where it'll drill and continue to go deeper without fully retracting out of the hole. The G241 would be it doesn't say this, but I'm pretty sure it's the deep pecking cycle where it does a full retract on every single peck. So we'll just kind of use that for a standard. Beyond that, it's pretty much just like programming any other CAN cycle. So we'll say G241. We're pretty much in position, so none of these values that we've already given.
Ethan asks which G241 is not in the
$12 programming workbook.
12, yeah.
I think it actually is in the $12 programming workbook. If you go to, because it's right here.
That's the Haas book, right?
Yeah.
$6.
Oh yeah. That workbook, which is actually the Haas programming workbook that I'm highlighting right here, that does not have any live tooling codes whatsoever. So G241 would be a lot like G83 in Millland. So this 241 is for live tooling only. So
what book is that in?
It's in this book right here. It's in the live tooling manual.
Tooling manual.
Yeah, I've got 2 workbooks here. The programming workbook is for turning cycles. So like on the final, you can use both of these books for reference for writing your program. And you'll use the programming workbook for we'll go over that too on the final morning. So I'll pull up the drawing, and then I'll pretty much guide you to places in the books where you can copy and paste your code and fill in your geometry. So yep. So G241. Now this X is going to be your depth, the depth of your drill. Y and Z and C are all positional codes. So what that means, I'll do this drill cycle for you, and then you guys will do the other side. So since this goes 750 deep, you have to kind of go back and look at where it is from the flat. So 811, you know that 811 is our starting plane, which is double because it's on the X. You also have to double your depth. So here's how I would do this. There's 2 ways to figure this out. You can take 811, this number here, 811 minus the depth, which would be 0.750. 0.750. Multiply that times 2, because it's on the diameter, your X is actually going to be 122. Because from this surface, it says to go 3/4 deep, which happens to be
3/4 from the flat.
Yeah, 3/4 deep from the flat. So I didn't really make it clear whether we need 3/4 of an inch of threads or if it just needs to be 3/4 of an inch deep. We'll just make it to depth, to the 3/4. So this would actually be X 0.122. Everybody see where I'm getting at? Basically the flat.
No.
This flat is the surface, is this surface, right?
Right.
So these 4 holes are 3/4 deep from this surface, which is 811 thousandths off center, right?
Right.
So when we milled this with that 1/4 inch end mill, we milled it at 1.622 because we're still, even though we're dimensioned from center, the program is programmed on the diameter of the part. That's what's confusing about lathes, is X is still always on diameter on a Haas. If you get to an Akuma, maybe not so much. So different lathes have different rules. So the reason we're at 122.
So what are we doing? Back figuring from from zero?
We're saying 811 minus 0.750 because we want our drill point to wind up down here, right?
Okay.
So it's 811 minus 50, and then we double that because we're still on the diameter. Clear as mud?
Up until the double it part.
Yeah, you can actually download.
I don't understand why we're doubling that.
Oh, because it's a lathe and we do everything on diameter on the lathe. Like when you tell it to cut this here, this 2.1, you don't tell it to cut 1.050 because it's off the radius. You tell it to cut 2.1 because it's on the diameter, right?
Right.
Well, you have to. It's the same rule over here. If you were going to cut a 0.062 diameter on the front of this, you'd have to tell it 122 or 124. You'd have to double it because it's on the diameter. Same with the drill point. It wants to be told based on the diameter from center where the point's going to stop at. By the way, the live tooling manuals, you can totally download them. You can download the programming workbook. And at this point, you could like go up somewhere and pay 15 or 20 bucks to have it put into a book form, because you can have that done on campus too. I think they'll charge, the printing place charges us $12 or $13 to do it, and that's why we charge $12 or $13 for the book. We just have them printed out off a PDF. All right, X point 122. The R is the retract point. So if our part is at 1.622 on that flat, we probably want to be 50 above that. So again, since we're on the diameter, we got to tell it twice that. So 1.622 plus 0.050 plus 0.050 will be 1.722. Everybody see where I get that? When we cut this flat, when we cut this flat, this is at 1.622, right?
Right.
Um, 50 above that is going to be 1.622 plus 0.050, but if we tell it that, it's only going to be 25 because it's on the diameter. So I tell it 100 when I want to go 50 because we're still on the diameter. Because this isn't really 811, it's 1.622, again, because it's on the diameter. So our R point has to be the same way.
Okay. Where
Right.
is the print in BB?
If you go into YC project, click on that,
Blackboard.
and then you can click on the YC project PDF, and then it should open up for you.
I can see on the screen. Okay, thanks.
Find it?
Yeah,
All
looks
right.
like it.
So at this point, we can just go around and do the other 3 holes. So we'll just say Z minus 0.831 and enter. Each hole has to be on a different line because it's going to do one thing at a time.
Dave says should be able to download any PDF or PowerPoint.
That's true. Chris asked, so it's just like a manual lathe. If you take a 50 thousandths cut, it's taking 25 thousandths off each side, and that is absolutely correct. Absolutely. So our next move will be X.
This is a lot harder to wrap my brain around than mill.
It is because your brain starts thinking X and Z and everything, and it's. I get confused too. In fact,
Yeah.
that's why Sam was calling me out on forgetting that Z move. X.
Well, my brain's telling me that X is just X, so you would on the
Right.
750.
Right. You want to, and the other thing that gets me is when I start working on this plane, I start thinking X and Y.
Yeah.
It's like a mill.
Yeah, me too.
So this would be, we're at Y 0.440. This would be Y minus 0.440. And we've got another Z move, which I would be tempted to call X, back to 0.169. Z minus 0.169. Minus 0.169. So those 4 holes are done. Let's save all that hard work. Scroll down a little bit. So we can actually be done with that toolpath, and G0 will clear the can cycle out. They give it a G80, which also clears out the can cycle. Since they're doing that, I will too. G0, G80, X 2.5. Oh, we've still got the other 4 holes to do on the other side, and that's going to be your all's job. I've given you this example up here. These are a little more involved because of the way that they're, like this hole has 2 different dimensions from this hole. These are both on the same, these are both at 356. But keep in mind, this hole's at 0.422 on Y, and this one's at 0.452. So your job is see what rotation do you have to rotate around to get to C. And then you'll have a G.
C180?
Probably. Or you could actually use H in this case. But that's,
why would you?
Yeah, that's homework. G what? X. You'll have an X move. You'll have a Y move. And you'll have an R move. It's like up here. And then you'll have an X and a Z. Nope, you'll have a Y and a Z. So this could be like this first hole. It could be this first hole. It doesn't matter which one it is. The only thing that matters is that you get the right dimensions in there. So the X in this case will be
the same size holes.
Actually, no.
We're not changing tools.
Yeah, we need to go back and change tools. Let's go ahead and leave this here. I was thinking they were all the same size. I'm going to copy the retrieval out of the book. I think I like the example up here better because it's more thorough. I'm going to say G0 and then tell it Y0 as well. And then it's pretty much going to be the same M9. We'll tell it M5 here, and then M9 here. Now, they have a lot of this stuff in a line by itself. I guess it wouldn't be M5, it'd be M135 to turn the spindle off. A live tool drive stop. And then we'll tell it 155. Now, technically, you would not have to tell it 155 if you're just going to another live tool. I just think it's a really good practice to do that, to do it that way. And I'm not going to zero out H. I am going to take it back to G18 and rapid to, see there, I'm just going to tell it G28 from here, or let's go Z0, G.1, let's get a little more clearance plane, and then G28 finally. So when you're doing your tool paths, your beginning and your end of your programs are going to be, your tool paths are going to be a lot the same. It's just the mental geometry that changes. And hopefully, it seems like I've been able to copy and paste this before. It's like sometimes it works and sometimes it doesn't. All right, so our next tool will be tool 4, E404.
I think so.
Now, what we could do is we could copy and paste all this up here and then use the same routine for our tapping cycle. But I think for good practice, we'll tap the holes very last. That way, if you ever broke a tap off in the part, you don't have to worry about it hitting something else. I tend to make my tapping cycles dead last. All right, so it's going to be pretty much the same rigmarole because it's radial tooling. We probably should have put that up here. Radial drill. And I'm just going to say G19, going down the list. We're going to put it on track 2. See, we didn't do M1. Another thing some people do is put a couple spaces between tool paths. It makes it a little easier to read. You can do. Everybody's got kind of their own style sometimes. So we've only really programmed 3 tools. Let's keep rolling here. All right, G19. What's weird is they give it a G19, G75 for each drill cycle here. I really don't think that's necessary. M154. And we're going to turn on our PM G97. which is inches per minute. No, it's surface feet off. G97, GP 2500 is about the same size drill. M133. We got different M code for the live tooling. And we need to position our X. 2.5 is our nice clearance plane, and Z.1. And turn on our coolant, M8. And so now we're positioning C, and you guys are going to program the holes for this side, which will be on the opposite side. So if this side is C0, you know you got to make that probably 180.
Mm-hmm.
Give you a spoiler alert.
Mm-hmm.
All right, so then from there, seems like I'm missing something. Is everybody good with that, or am I missing something? It's probably a good idea.
Dave says whoops.
Boobs?
Whoops.
Whoops. Oh.
Yeah.
Should be able to, okay, so back to here. So at this point,
So we're at clearance.
yeah, you're at clearance. You're going to position
Now
C.
we just need a position.
Yeah, this will be your G240. Actually, the example is down here on page 30 is where the example is that I'm using. It'd be the G241 line. And we'll also need an F. Then you're going to need a Y and a Z move.
Mm-hmm. We already have a Y.
Well, it depends on which hole you're drilling, because this pattern has two different Y's. If you start with this hole, you'll need another Y move right here because it's got a 452 and a 422. You start with this hole, it can be the same.
Yeah.
I would probably start with this hole because it's closest to home, and move to that hole, and then these two last. So again, you'll have another Y, dot, 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 another Z. Then for the last hole, would just be a Z move, because you'll be in place on Y.
Okay, but don't you need a Z move on the first hole?
Yeah.
I don't see one.
Yeah, you're right. Z. That's going to be a simultaneous axis movement. Not a big deal because we're at X2.5 here. And so it should move everything in place and then go down to the R point at that point. If not, you would have to position Y and Z, which it might be a good idea to do up here instead of there. A little bit safer.
Mm-hmm.
And then we'll pull it out of this. We don't want to be crashing stuff. So then this line.
We also don't have a modal command.
Do what? So this will all.
We don't. It's not. We haven't given it a G01 or G0 command before that.
That's true. Technically, it's left and rapid right here.
Right.
But it's a good idea to put it in this other line here for sure. There we go. Now we can tell it G0, G80, Z, for X, 2.5, put it back on clearance. And we're going to take it Z.1, the M9, and Z.1, M135. Starting to memorize the codes again. I use them but once a week. Tool drive stop, Save my work. And then I'm going to copy this other, make sure I have all my codes lined out. Because the next thing we're going to pull out is the tap. Then we'll be done with this project, and you guys can finish it up, and then I'll grade it. So those of you that have done the first part of it and finished and turned it in, I won't have to look at that part again. But you can just submit the whole thing. Let's see. So we're going to tell it M155. Disengage C-axis. Already turned off the coolant. I'm not going to zero out H, but I will tell it Y0, probably in this line. Always a good idea to zero out Y. I know on Akumas it's a bigger deal than it is on Haas, but you don't want it going back to a tool change with Y being not at 0. Okay, M155. And at this point, we can just say G28 and take it home. M1.
Ethan says, "Hey Addison, pause the recording so it's easier to load."
Okay, time to pause the recording.